hard and things get out of hand. Little did I know that I would see my loved ones be affected by hands that were bent and swollen and end up volunteering at a hospital where many of the elderly were deemed fall risk. Now, through inquiries, I found out that the degeneration of skeletal muscle, the muscle that attaches to your bones and aids in your daily movements, is associated with conditions like arthritis, as seen in my family members, as well as sarcopenia, as seen in the elderly patients. In these conditions, skeletal muscle mass significantly declines with age. Now, that leads us to my research, where our goal was to build a skeletal muscle model such that we would be able to constantly test what was going on in these diseases and ultimately develop treatments for them. In these conditions, while existing cell culture models had cells growing in two-dimensional cell culture plates, these cells often detached from experimental surfaces, and we wanted to find a better way to mimic the attachment found in a three-dimensional human body. And that was by using the bioinks bioprinter. Now, how does this bioprinter work? Similar to a normal printer, which takes in ink and outputs colored pieces of paper, the bioinks takes in mixtures of polymers and bioinks, otherwise known as hydrogels and polymers, and it outputs our skeletal muscle models. Now, first we needed to consider if we're going to print cells in this bioink, and we wanted to make sure that they're able to grow and survive in this bioink over time. So by counting cells embedded into the bioinks of these different time periods, we found that the cells increased in number after maintaining them for 20 days as opposed to a 6-day period, indicating growth. Now, before we bioprint the skeletal muscle, however, we also need to design it. Designing often involves multiple softwares such as G-code programming, Adobe Illustrator and Blender, as well as CAD 3D modeling software. Now, this is what some of our sample prototypes look like. On the left, you can see a test design for skeletal muscle, while in the middle and the right, you can see some of our attempted hand models, incorporating skeletal muscle stem cells as well as fibroblasts or connective tissue cells. As you can see, the bioinks potential is absolutely incredible. Not only do we have one output, but we have up to 3 outputs at once here. This implies the bioprinter essentially has the potential to print multiple structures, such as muscle on one, bone on another, as well as vascular networks on the third of its 3 outputs to create a complete hand with one machine. Now, why might this matter to everyone? Well, the sad reality is things may change as we all age. Arthritis is real, sarcopenia is real, and we're hoping to aid in treatment development with a model that consistently mimics these diseases, all without having to use real patients. By conducting this project, we ultimately hope to overcome these challenges by creating a model that can lend a helping hand to all. Thank you.